Hi there. Today, I recently read a blog on GitHub, engineering blog. I talked about how they changed their approach in processing 300 million pushes every day. Every commit and push you make, it generates one push. And if you imagine across the world, so many people are doing it, so that results in around 300 million pushes per day. So what I'll do in this particular video is I'll go through that blog, and then I will also talk to some of the learnings that you can apply directly in your day-to-day learning. So what that would do is, it's good that you read a blog, but then how do you take learning from that so that you can really apply? That's where the real learning and real application happens. So stay tuned for that. The blog link is here. You can go. I will provide this link in the link below. But essentially, this is what something that was happening. They whenever you do a push, right? When you push your commit in, there's a whole big monolith that runs in, and that will trigger a repository push job. What this push job will do, it will call different tasks to do. It has got a lot of things to do. I think what here is mentioned, there are like 50 plus tasks that gets executed. Now the problem with this approach is that these tasks are all sequential. So when it is sequential, it means that your latency increases. And there are other problems as well. So I've listed down the problems that can happen. uh, Failure in one of the system can break everything. So if this particular job like PR callback failed, everything just blocks, and there's a huge blast radius. And it also becomes hard to figure out where the problem occurred in this particular thing, because you need to kind of look at the logs from the entire job process to figure out where it has happened, and then you need to troubleshoot. It becomes harder on that sense. The other aspect is any change that you have. Say, for example, a change happens on code switch callback. You need to really test all of the different combination that can go through it. Similarly, if it goes way below the process, it becomes much more longer for your testing to go through it. Yes, you have automated tests, but you need to run so many of them to get to ensure you have that confidence that there is no problem in that. So these are some of the problems that they had. Now, what they did about it? What they did is they introduced Kafka, and Kafka created this job queue bridge where they split the one big job into multiple jobs. And what this did is each of these jobs became independent, and now you can see they are all can be run parallel as well. So when they run parallel, which means your performance improves automatically. The other aspect is because now you have specific jobs. If there's an error in this particular job, say issues on push job, but then only that particular job failed, and rest of your system is still intact. And you can easily troubleshoot, because if you have an alert on that particular job, you know where to look at. So you can really recover fast as well on that one. So some of the advantages there, you see that this is a loosely coupled system, so there's no interdependencies on these things. Now bear in mind, like when you try to do this kind of an approach, there would have been a lot of work done to isolate different jobs. It may not be as clean as it looks here. There would be a lot of interdependencies which would have been the first reason why they were sequential. So there was a lot of effort done to to isolate different modules and into different jobs, and that's not reflected in the blog as well, but I just thought I'll call that out. And then yeah, monitoring becomes easy, your scaling can increase. So what that means is, if this particular job is being run many times, or you need more power for this particular job, you can increase the number of instances that can run this job. So that's another. So, and you can keep the other ones lesser. So that way, you're only increasing the process. I mean, increasing the job instances only for the process which needs more. The other ones remain the same. But in the earlier approach, where you had sequential, you have to kind of add more resources to the entire push job. So that would become harder. So those are the things, and you can have lower latencies, and similarly the reliability improves as well. Now, what it means to you? Now, you may not have the problems of scale that GitHub had, right? You may not be processing 300 million pushes every day. So, but you may have systems that are tightly coupled. You may have huge classes that does hundreds of things. You may not have considered the impact of retries, or your code is hard to test because of these many processes. So, how can you really apply this learning? So make your classes easier to test. You try to break those classes, bigger classes, out into smaller pieces. It's very easy. to detect when you want to know how to, how to figure out if a class is easier to test. It's like when you write unit tests, and if you find that you need to use a lot of mocks, a lot of uh, more advanced technology to, more mocks to just test one piece of change, it means that class is doing many things, and you can kind of remove some of the things into a separate class, and then that class becomes testable. And then in the main class, you just have to test whether the logic still works end to end. And then you might have tightly coupled systems. Now you might think about, like, can you make them asynchronous? And what are the impact to it? Like, one of the things that we did was we had two tightly coupled systems, and we did introduce this similar pattern where we introduced a Kafka. So the source system would just send the request to the Kafka, and then the source system forgets about it. The destination system pulls it out from the Kafka, does all the processing, and then sends a call back, and then the source system will update it accordingly. So that way, now the source system doesn't have to wait. The thread is not waiting, so they can do more tasks and so on. Then there's the other thing is, can you break down a big process into different modules? So this is what I said about these jobs. They broke down into this different jobs. Now there were dependencies obviously between these jobs. It may not have been visible at a high level, but if you look at the code, it might be. So they have done the hard work of identifying those dependencies and then isolating them into different processes, and that's how they broke that. So you can also think in that line, can you break into different modules? There might be a big orchestration, you might want to break them into different modules, and which would make it easier to test and maintain. The other aspect is, when there are integrations with multiple systems, is there a way you can retry them? So the retry is a very tricky topic that you need to know. Like, it's a good concept to have a retries in, because that will mean that you are building system robustness. But that also means that you can get into this thing called a retry hellhole, where every system starts retrying whenever there's an error happens. And what that means is, then there's just the system is just in a retry mode if an error occurs, because all the systems are retrying on different uh, errors. And what that means is that the load on the system increases exponentially when something wrong happens, because each systems are retrying, and they have the new requests coming in, and the whole thing will just start throwing up errors and slowing down, and then start throwing errors. So you don't want to do that. So always be aware about how are you going to implement retries, and yeah, what are the impact on the downstream systems if you're implementing a retry, and what are the impact on the upstream systems, and do you really need a retry, and so on. So those are the questions you need to keep in mind when you are doing this. So yeah, so that's all I've covered. So the main thing that I've covered is, like, what are the issues that GitHub was facing in terms of their systems, like processing 300 million operations every day, and what they did, and then how you can implement what it means to you, and how you can apply this learning. So that's all, folks. Do drop in a comment if you have faced similar challenges, and how did you overcome them. It would be interesting for me to read through them.